Have you ever wondered why an app doesn't instantly crash when millions of people simultaneously hit buy for a major concert ticket release? To understand how they survive, imagine a typical grocery store with just a single cashier working the checkout lane. If 500 customers sprinted at that one cashier and threw their groceries onto the belt all at once, the system would break. Computer servers work the same way. If a server receives hundreds of complex requests in a single millisecond, it gets overwhelmed and shuts down. Even the most powerful computers have limits. Unmanaged simultaneous demand leads to failure. In the real world, we solve this chaos by forming a single file line. Software uses this exact same strategy. Developers build an organized digital waiting area called a message queue. This queue protects the server by catching all of those sudden incoming requests and handing them over to the computer one by one. Providing a secure space to wait is the secret to keeping massive systems online during a rush. Let's look at how this works. The app or user making the request takes on the role of the producer. The shopping cart full of items they push forward represents the message. Each message functions like a digital to-do list or a packet of data waiting to be processed. That to-do list is placed onto the conveyor belt. This belt is the queue itself, keeping the carts in order. The cashier scanning those items acts as the consumer, the server that does the actual computing work. This setup separates the user's request from the server's immediate workload. But what happens when the digital queue gets too long and users have to wait for their tasks to finish? A store manager would see a long line and open up more cash registers. Software does this through auto-scaling. When the line gets full, the system automatically spins up more servers to clear the crowd. These parallel servers divide the work, whether they're resizing photo uploads, sending email blasts, or processing credit cards during a sale. The length of the queue tells the system exactly when and how much to grow. This organization enables a strategy called decoupling. From your perspective, it means the app instantly says, "Order received," because it only has to drop your task in the queue. You don't have to wait for the work to finish. From the server's perspective, it means the computers in the background can work through the line at a safe, steady pace. Decoupling breaks the direct link between a sudden rush of users and the server's immediate capacity. The next time you click Buy or Upload and see a loading spinner on your screen, that delay shows your task waiting its turn in a digital checkout line. The world's most reliable apps stay online by prioritizing simple, clever organization.